2I Landing Ship Tank, LST, Haiyangshan, number 936, has a new turret installed on its bow, replacing the HPJ-76F 37mm anti-aircraft turret. There are also 3 shipping containers. The entire railgun measures roughly 65 feet from turret rear to barrel muzzle, with the barrel itself about 33 feet long, and 12 to 20 feet in diameter. Such a wide barrel provides room for the parallel magnetic rails that propel metal projectiles to speeds of over Mach 7. The turret spotted indicates the presence of a railgun. It's large, for one, with a barrel that measures 26 to 33 feet in length and 12 to 20 inches in diameter. That's 2 to 3 times the cannon caliber of conventional tube artillery barrels, which generally have a diameter to caliber ratio of 1.25 to 1 diameter. Alternatively, a 350 to 400 mm naval mortar could explain the barrel diameter and length, but such a large mortar would be hilariously unnecessary. Due to weight issues, there is virtually no reason for a conventional cannon to have this kind of diameter to caliber ratio, and so the barrel size likely accommodates magnetic rails to propel shells to hypersonic speeds. The shipping containers are another indicator. It's likely they contain some sort of power equipment, like generators or capacitors. Its barrel length makes the Chinese railgun similar in size to the BAE 32 megajoule railgun built for US Navy testing. The BAE system is designed to fire 22-pound projectiles at Mach 7 speeds to more than 100 miles. Despite previous efforts to install this multi-megawatt railgun on the USNS Trenton, shifting budget priorities in late 2017 may mean that this railgun may never be carried on a USN warship. The United States had earlier planned to install a railgun prototype on the USNS Trenton fast transport in 2016, but this was postponed for budgetary reasons. In fact, current railgun research funding has been reported as in trouble, as the Pentagon focuses first on equipping conventional naval guns with the railgun's low-drag, high-speed ammunition. China's advancing work in railgun and other electromagnetic technologies shouldn't come as a surprise. In addition to copious open-source research by Chinese scientists, a program led by Rear Admiral Ma Weiming has in the past hired Chinese military engineers to build state-of-the-art electromagnetically assisted launch system catapults for future Chinese aircraft carriers. The program also built integrated electrical propulsion systems to meet the electrical needs of future Chinese warships. And keep in mind, just because the railgun is there doesn't mean the railgun actually works. Engineers for this test, as with all other railgun work, will have to overcome formidable challenges in material durability, power storage, and projectile guidance. If successful, however, it would offer China a game-changing capability. A working railgun would likely be installed on future versions of the Type 055 destroyer, which makes sense considering the vessel has been reported to have IEPs, which would meet the electrical demands of railguns and other direct energy weapons like lasers. In terms of benefits, the railgun's hypersonic long-range projectiles would be perfect for cheaply and quickly knocking out high-threat air targets like ballistic missiles, aircraft, and even future hypersonic vehicles. The long range would also come in handy for missions like anti-ship warfare, supplementing shorter-ranged anti-ship ballistic and cruise missiles. Finally, such long-ranged artillery would be a significant addition to long-range bombardment of ground targets.